Hi, my name is Marcus, and on this video I'm going to show you how you can take advantage of MySQL's multi-CPU capabilities on its InnoDB search engine. Now, one particular task that is common to developers, data scientists, and database administrators is loading data to a database. Usually, when you have a lot of data to load to the database, you use MySQL's load data in file command. But the problem with that is for very large files, it can take a lot of time to load the data. And one of the reasons is that MySQL does not use parallel processing when you're loading a single file. It does not divide the task into multiple processors. So to overcome that, I wrote a small Python program that basically what it does is it divides a CSV file into multiple chunks, and it processes each chunk in a separate thread, effectively loading the file much faster. Now, this code is available on my GitHub account that you can see here, and you can also find there the database schema and the dummy data that I use for this particular test. There's this library that it uses called File Cleaver that does the chunking into different pieces. Now let me show you the code for this program. This is the code for the program. And you can see here that I'm using this library, File Cleaver, that you can find on this particular GitHub account. It should be available on pip, but I could not install it on pip, so I downloaded it directly from this user's GitHub and installed it locally. This is the data loading procedure. You can see this is very straightforward. It uses the same command, load data in file. But when you call this program and passes the number of threads that you want to divide this task into, it actually divides the files into the same number of chunks. And it does that by calling this procedure called cleave. You can see here, and you pass to it as an argument the file that you want to split and the number of chunks that you want to split into. So basically, chunking the file is a very fast process, especially if you select a fast drive for the temporary files. In my case, I'm storing the temporary files that it generates on my TMP, which is stored on an SSD drive. So let me show you the program. Let me show you this program working. Okay. First, we're going to create the database schema with the test table. So let me call this script that I already created with the schema. Okay. Yep. Okay. So it's done. The database and table is created. Now let's call the program. First, let's call the program with a single thread so that you can see the difference in performance between using multiple threads or just a single thread. This particular file that I'm loading has 20 million rows. Okay, so it does take a while to load. Okay, the process is done. You can see here that it finished loading 20 million rows in 81 seconds. Now, let's try the same process using 4 threads. I'm going to clear the database again. Okay, the database was recreated. And now let's call this with 4 separate threads. Now it's splitting the file in 4 chunks. You can see this was a very fast process. It only took 2 seconds. And it's loading the files in parallel now. Okay, all done. So you can see here that the whole process took only 43 seconds, which is almost half the time it took to do this in a single thread. So you can see this is a very good way to load when you have a big file to load into MySQL. Splitting the file and load it in parallel is a very good way to approach this task, so it takes less time and you can focus on the important stuff. Now, just a small detail about this is when you are using statement-based replication on MySQL, you cannot do loading in parallel, because for this to be effective, you need to set this particular option here. Let me show you. You need to set this particular setting here, which is the auto increment mode for InnoDB. You need to set it to 2. Otherwise, each load data in file will lock the entire table, and effectively you won't be able to load in parallel. So you should read this particular link here. You should follow this link if you want to see the details and see why you can't do this if you're using statement-based replication. So that's it for today, and thanks for watching.